My name's Paul, VK3CRT. Welcome to this video showcasing the development of what we're calling the Star Nextion Dashboard. There's a lot to talk about, but I'll be focusing on the Brandmeister network in this video and how the display supports that. But also the display supports the Brandmeister, VK-DMR, which is the Australian version of DMR, and D-Star. I say we because Alan VK3BV has been a key part in this development as well. The project was started for two reasons. First, I travel a lot in the car to and from work, and I wanted a display that didn't jump around screens when calls came in, and it was easy to read, so limiting the driver distraction. The other reason is Alan is vision impaired and legally blind, so he wanted a display that was also easy for him to read and other vision impaired operators, as well as the screen not flickering around the place. So the video will show the current design and how things are displayed, but it'll also give you an insight to the Nextion editor, which is on the screen at the moment, as you can see. The Nextion editor, by the way, that you can see here is the English version. There is the Chinese version. The Chinese version works with the TJC. TJC is a Chinese version of the Nextion, same company. Nextion, of course, is the English version, or the European version, as they say. But the Nextion editor you see here is the English version, and it works with the Nextion display. Chinese version works with the TJC. They are not compatible, so if you compile the file up in the English version and try and load it into the TJC, it won't work, and vice versa. So just be aware of that. If you're going to buy a cheap TJC display off the E of the Bay, you'll need to use the Chinese version of this editor. So if you can read Chinese, terrific. If you can't, well, you're going to have to buy the English version and the Nextion display. So when we looked at the real World Wide Web, there was really nothing that we thought would meet our needs or our goals. So we started the long learning process of finding out how Star works, the ON7 LDS screen and what all that meant, and what I call the Nextion Advanced driver. So the Nextion Advanced driver is something that you install afterwards. It's got a richer content with location information, and it also allows the display to talk and command the Pi, so to shut it down, to pause it. So that's also supported by the display. So the Star, just as a thing to let you know, Star sends MMDVM status messages from it to the display. And these are used for all sorts of things: call start, call ends, all sorts of stuff. But what we found was that using those when you had, say, a busy talk group like talk group 91, or you're on a talk group that was quite busy, doesn't have to be 91, and you're on a slow network connection or a mobile phone connection, or for our American friends, a cell phone, then the display wouldn't work too well. It would miss things. It wouldn't wouldn't stop calls, displaying calls when they ended, things like that. So we tried the high-speed version of the ON7 LDS, and that didn't really help. So what we've done now is we've coded so that it's not using MMDVM statuses, apart from call ends and a few other things. But primarily now the display acts upon what's coming in from the network, and it's much quicker. I've tested it with Talk Group 91, our local VK-DMR network, the other day, and it seems to work very well. So that speed issue and that performance issue seems to have gone away by just using direct actions from the network, that information that comes in. You'll see that when I fire up the editor properly. So DMR in Australia is called the VK-DMR network. That uses time slot 2. Brandmeister, of course, time slot 1. and of course D-Star is its own thing. The display will support any of those modes, any of the time slots. It supports a single hotspot or a dual hotspot, so it's quite flexible in that way. In the future, we're looking at doing other networks, like for example Fusion. So at the moment it supports VKDMR, as I said, the Brandmeister and D-Star. You can actually have a dual hotspot connected and the display will function quite okay with those dual time slots working. So it's been written to support time slot 1 and time slot 2. Alright, so let me get rid of my little face here and so you can see the screen better. So as you can see, this is the Nextion HMI editor. Current project I'm working on at the moment is version 2, and this is number 18 of that. So this is a released version that was using the MMDVM statuses, and these versions now don't use that MMDVM status. So as you can see here, here's our screen. Now this is the graphic here that you can see. So this is the graphic that Alan came up with, the color scheme and the design. So this is how he's really helped with how this can be designed to be easy to read, and quite good for vision impaired. And also too, it helps me in the vehicle because I can easily see this in the car. So these things here you can see, this network is actually a text box. So here you have all the things you can put on the display, the text, the scrolling text, numbers and so forth. So if I click on here, you can see that's a text box. Over here is the attributes. So I can change the settings of this particular text box. For example, here it says global. I can change it to local. I've got these set to global. Just to explain that, global means I can call this or send anything to this text box from any screen. If it was local, I couldn't do that. It would only work with this particular page, as they call it. And here's your pages here. All right. I'm not going to go into this in great detail. I will if somebody else wants me to. Over here, of course, you've got your normal stuff. The compile button. So if I push compile, you see this is your compile screen. It's got the blue here is just saying I've got a couple of things on top of each other. It's not an issue. The debug screen, which I'll be showing you in a minute, and the upload. Upload means upload to the display directly. I don't do that. I prefer to compile it, put it on a SD card and then load it up, load the display up through the SD card. If you have an error in your code and you're sending it off to the display, that you could run the potential of corrupting the display. So I'm particularly nervous about that, so I don't do it. If you're fine with it, go for it. It's an individual choice, but I don't do it. I basically come up here and then create the TFT file, which is a combined file, to an SD card and load it up through that. Also down here you can see there's my code screen. So this is where I've actually written the code for individual things on the display. So I'm going to go into the debug now and compiles. Now this starts counting down, waiting for Pi to fire up and send commands to the display to say it's alive and well. You can see here I tell you that it supports the ON7 LDS LS3. That's the screen layout where you can do your own things, or you've got 2, which is a fixed thing, and 1. Also, this supports LS3 high speed. You can change that in the setting windows, but I don't do that now because I basically run it on the normal speed. Now, before that times out, I'm going to get out of that because I can, because otherwise it's just going to fail. Click on home, and here's how the screen will look when you first fire it up. So it'll have an IP address in it. Very handy if you're on a mobile or cell phone, because you can see if you're connected to your local network or the actual mobile network. Your last station display, the talk group, the time slot, the bit error rate for if you're using when you're PTT, the duration of the call, the status light, which will be green when it's waiting for something to happen, red when you're PTT from your radio, or blue when it's on a network call. The location. Now the location works when the Nextion driver, advanced driver, is installed. At the moment, I'm not going to show you that. I'll show you that in another video. But that's where your location information will go if you're using the advanced driver with all the extra location bits. Call sign, of course, name, and of course DM is digital mode. So D-Star, DMR, Brandmeister or VKDMR. Power button, turn off or restart, and the cycle button, which turns the MMDVM process on or off. I won't show you these this video because there's a lot to go through. I'll show them in another window. So normally it fires up, you get the IP address. So in here I've actually got these some of the commands and strings stored. So if I click on here, you'll see here that I've got this in here, which is MMDVM status 16. The network message that's going to come in, this time it's time slot 1 because that's what I'm using at the moment, which is the T0, T1 which is a talk group, and T3 which is my IP address. So 16 is the command that comes in from Pi to tell the display that it's an IP address. So if I click on this display which simulates the Pi talking to it, nothing will happen because I haven't run these commands yet. If I run the commands, you see it just did that. Now if I click on the display, it will come up with my IP address because it's 16, and it's only 16 because it's ignored these things here because it's only 16 here. So there's my IP address. Now I can change this to something else. Let's make it a 9. Now if I click on here, nothing's going to happen because I haven't actually run the command. So if I run the command, click on here now, which simulates Pi talking to the screen, you'll see it changes here. Now if I click on this number 2 again, it goes back to the 171. That's because I didn't save it. So let me just try and change it again, go to a 9, and in here this is the save button. I click on that and I can save it to 1, 2, 3 or 4. Of course I'm going to save it to 2 because that's where I'm working at the moment. Save to 2. Now every time I click on this it'll come up with that, so I've stored that in the location. Okay, now I'm going to simulate a PTT from my radio. So I know that that's a 65 coming in from Pi to the display. The network will have a 1, which is time slot 1, R, which is the RF signifier from the network, and my call sign, the talk group 91. Have to run these commands first, otherwise nothing will happen on the display. So I run that, that stores all the values in my parameters, or the parameters into my values I should say. Click on the display and there you can see talk group 91, time slot 1, no bit error, which I assume there wouldn't be, and the timer starts. And this has gone red to show me that I'm actually in a PTT, and it's brought up the Brandmeister network here for the digital mode. All right, now to stop that, I know that it's a 64 from Pi to the display, the status message. So I've got to run that. Click here, and now the call's stopped. So I've now assigned myself a chunk, if you like, or whatever, and now I'm on talk group 91, time slot 1, and I talked for 27 seconds. So now what I want to do is simulate an inbound call from the network, so a normal QSO. So if I click on 1 here, you can see that I've got MMDVM status is 0, because remember I'm not using status messages anymore for incoming calls. Here's my network message, a 1 for time slot 1, an N for a network call, my call sign, my name, the talk group, the IP address, which won't change because I'm not making this 16, so it'll stay the same. And these down here will be for something later on I'll show you. So yet again, if I click here, nothing happens because I haven't run these commands. So run the commands, click here to simulate Pi talking to the display. And as you can see, PK3YYY, it has my name. All the talk group stuff stayed the same. But here you can see the timer starts running and it's blue to tell me that there's an inbound call coming from the network, or a QSO is in progress. Now, what I can do here is I can click here and nothing will change because nothing's changed within these down here. So if I now wanted to change something while this was in progress, I can. So I'm going to leave that run, and I'm going to change this to, I'm going to delete this, I'm going to change that to an A. Run the commands again, simulate the thing from the display, and it changes that display. It doesn't change anything else. So it's just showing how you can change these things on the fly. I'm now going to stop this QSO, or this display counting. I know that it's a 64 coming in from, and that's a call end. We also look for call ends for other things as well, just to make sure we're going to actually stop the call when the call stop message comes through. And sometimes this MMDVM 64 can be missed, but we actually capture it in other ways as well. So I'm going to run the commands as I normally do. Click on the display and you can see it stops. So that's basically how the display looks with an inbound call, or if you PTT and so on. So now what I want to show you is the last station. So last station, as you can see, there's nothing here at the moment. If I click on here, which is these power buttons or the stop start, it'll come up with a message basically saying that the Nextion driver isn't installed or the strip CSV is not installed. So these buttons are disabled because you need to install the driver or the advanced driver if you like. And you get it from my GitHub, or you can get it from GitHub where the actual code sits for the Nextion advanced driver. But this is what comes up. But why I did this also was to show you that when a call ends, the screen itself does an exit. And you'll see it brighten and go dark again if you've got that set. And when it does that, we capture the last station in that last station area. But I'm just going to simulate that by doing this here. Now if I click the home button, you can see that it's stored my last station in here and my name. There's no other further locations, so that's all fine. So what I'm going to do now is I'm going to simulate another call coming in. So I'm going to actually set this to 0 because I've got to reset that parameter value. I'm now going to change this to, say, my call sign, CRT. Take that off. So I've just changed that so I can see a difference. I'm going to run the command. Now don't forget, if I don't save this and I click here again, it's going to go back to what was in there previously. Simulate Pi sending a message to the display. And as you can see, VK3CRT, my name, and it starts ticking along. Now, I actually wanted to change my name and I forgot. So what I'm going to do here is, while that's going, I'm going to delete this and let's make it Fred. So I'm going to run the commands again because I am changing a parameter a value in the parameter. Run the commands, click on here and you'll see it changes to Fred. Now I'm going to stop that call coming in by going 64. So this is all real time, of course, when you're running it in the display. This is obviously just the diagnostics tool. I will actually put a video up later on of the display and it's doing its paces, just to show you how it looks like in real life. Hit the run command, click here to simulate Pi talking to the display, and you can see it stops the call, that goes green, and the timer stops. Now what I'm going to do is simulate the call exit on the display. So I'm just going to go back into here, go back home, and now you can see that the last call coming in was VK3CRT and Fred. So this updates all the time. So this continually updates so you can see the last call come in. So if another call pops in here, so if you're in a QSO, for example, you'll always have the call that was here come down to here. Your PTT doesn't affect the display. The display stores your call sign or your radio detail call sign in the memory, so you don't keep popping up here and deleting it. So it will never store your call sign down here. It always stores the call sign that is actually being put up here, but your radio will not cause this screen to clear. It won't actually put your call sign from your radio into the screen, because there's not much point really, because you know your own call sign. So that's it for the Brandmeister network. Now, if I wanted to go to the VKDMR network, that would be a different set of commands because I'd be using time slot 2. So then that would have VKDMR up there. All right, so I also said that this supports D-Star. So what I'm going to do here is click out of that, and then I'm going to restart the debug. All right, same thing comes up. I'm just going to stop that, so we don't want to watch that. Now at the moment you can see the display showing nothing. Now Pi is booting up. Now for D-Star, I know that D-Star stands a number 2 to the display to tell it that it's D-Star. So DMR has a value, I think it's 3 from memory. 2 is D-Star, another one for Fusion. So that's how it signifies the type of network. So I'm going to change that to 2. So all I'm doing here is basically changing this to 2. So it's going to ignore all this sort of thing because the value here is only a 2. I'm going to run those commands. So now what will happen when I simulate Pi talking to the display is that, and it changes the digital mode to D-Star. Also, you notice that it's changed it from TG to reflector, REF. Now, if I had to put something in here, it would actually have the reflector and the mode. So, and also bit error rate and the thing's the same. I haven't got these set up at the moment. I didn't think it was worthwhile putting those at the same time. I just wanted to show you that. Now what I'm going to do is I want to go back to what this was before. So what I'm going to do is click on 4 again. And you can see that it changes to 42. I know that 42 is an inbound call for D-Star. But again, I've got here, it's an R for a radio coming in from your from the network, a VK3 CRT, and that's my ID. Okay, so I'm going to run these commands. I'm going to click on here, and as you can see, the status light goes red, and the timer starts. So now what I'm going to do is do a 11, which is a call end for D-Star. Run the commands, click on the display, and you can see it stopped at 18 and it's gone back to green. So now what I'm going to do is simulate an incoming call on D-Star. So come in here, and it's 42 is an incoming. It's the same actually as the one for your radio. 42 is incoming, okay, for both. But you can see that's an N. So we look for the N here or the R. So as you can see, I've got Alan's call sign in here, VK3BV. So I'm going to run this command. I'm going to then click on here, and as you can see, VK3BV comes up. There's no name from the D-Star that comes up in here. It's not provided. Country is Australia, and as you can see, we've got the flags here. So we've implemented flags on the D-Star mode because we can, and there's a room to put it in. So if you're in America, it comes up with the American flag, UK comes up with the UK flag, and so forth and so on. I'm just going to stop this call now. So it's number 11. Hit the run commands, click here, and you can see it stops, and also puts VK3BV in here. So this also tracks the calls coming in. So I'm going to click on 3 here again, and I'm going to change it to my call sign just to show you this. So CRT. All right, hit the run command again, click on the display to simulate the actual Pi-Star talking to the display. Comes up with my call sign, flag stays the same because it's still Australia. All right, I'm going to end the call with an 11, hit the run command, click here, and now you see it puts my call sign in. So this progressively updates the display as it goes along, and then it's first in, first out. So this will keep cycling through. So that's about it I wanted to show you for now. I hope this has been good for you to see how the actual editor runs, and also too the display that we've been doing. It's been a long process. It's been about 18 months so far to get where we are. we're looking at doing the 4.3, the 5, the 7, and thanks to Alan, we've now started work on the 10. The code is trying to be designed to be display independent. So for example, if the display supports a real-time clock, then we'll use the real-time clock. If it doesn't, we won't. The only thing we have to change with the code is the actual graphics, because obviously the graphics between the displays are different, as well as the font sizes. But hopefully we won't be able to do too many, we won't need to do any code changes, because if the display can support the particular feature, like as I said, the real-time clock, then it will. So we're trying to keep the code display independent, if you like. If the feature's there, we'll use it. If not, it doesn't matter. So that's about it for now. I will put some more videos up later. I will show you something else though, just before we go. I'll just go back to this screen here, and I'll come here, and I wanted to show you this. This is what we've also done for to help with the vision impaired. So I'll just generate a inbound call for a minute. So just do this, run that, and this is I'll run through this very quickly because you've already seen this. And and 64 run. Okay, stop that. And then I'll go to here and generate an incoming call. Go here, go there. So that's all fine. Now what I'm going to do now is I'm going to click on here, and as you can see, it magnifies the screen. So if you can't quite see the call sign, you can click on that and it magnifies the call sign for you. Clicking back on here brings you back to there, and it's still running in the time. And it's also now put the call up here. I can click on my name and it brings up my name in a big screen as well. Thought it might be worthwhile showing you, as well as some of the things that we've also implemented. So again, to stop this call, it's basically 64, sorry. Hit the run, that, and it stopped. All right, well that's it for now, and hope you, as I said, you've liked this. I will put some more videos up, as I said before, but until then, 73, and stay safe. VK3 COTs bidding you farewell for now.